Right now, every clock on every wall on Earth is quietly agreeing on something strange. Not 10, not 100, 60. A number so old it predates your language, your country, even your religion. And almost nobody stops to ask why. So let's ask it. Why 60 seconds in a minute? Why 60 minutes in an hour? Out of every possible way to slice time, why did humanity land on this one? And why has it survived every single attempt to replace it? Let's set the rules first. We're not just chasing a fun fact. We're tracing a decision made thousands of years ago by people who had no clocks, no calculators, and no idea their choice would outlive their entire civilization. We're going to follow that decision from the mud brick cities of ancient Mesopotamia all the way to the atomic clocks humming in laboratories today. And we're going to ask the harder question hiding underneath the trivia: was 60 ever actually replaced? And if so, why didn't it stick? Here's what the history actually says would happen. Around 4,000 years ago, in the region we now call southern Iraq, a civilization called the Sumerians was doing something almost no one else on the planet was doing at that scale. They were counting in base 60, not base 10, like you and almost every culture since. 60. Why 60? Here's the twist most people never hear. 60 isn't a random number. It's one of the most mathematically convenient numbers you can pick. 10 can only be evenly divided by 1, 2, 5, and 10. 60 can be evenly divided by 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60. 12 clean divisors. That matters enormously if you're a farmer splitting land, a merchant splitting grain, or a priest splitting a day into equal portions for rituals. Base 60 doesn't leave remainders. Base 10 constantly does. The historian Otto Neugebauer, one of the most influential scholars of ancient mathematics, spent much of his career reconstructing exactly how the Babylonians, who inherited this system from the Sumerians, used sexagesimal math for astronomy, land division, and trade. His research showed something remarkable. This wasn't a primitive counting habit. It was, in many ways, more sophisticated than the system we use today. There's an even more human theory for where 60 came from in the first place, and it starts with your own hand. Some historians of mathematics, including work popularized by the mathematician Georges Ifra in his sweeping history of numbers, point to a simple counting trick still used in parts of the Middle East today. Use your thumb to tap the 3 finger bones on one hand. 4 fingers, 3 segments each. That's 12. Now use the 5 fingers on your other hand to count how many times you've cycled through 12. 5 sets of 12. That's 60, counted entirely on 2 human hands, with no tools, no tablets, and no writing required. If this theory holds, the number that now governs every clock on the planet may have started as nothing more than a clever way to count on your fingers in a marketplace 4,000 years ago. But counting objects is one thing, counting time is another. So how did a base 60 number system end up governing the clock on your wall? That leap happened in the sky. Babylonian astronomers were obsessive sky watchers. They needed a way to divide circles, angles, and the movement of stars into equal parts, and 60 was already their go-to number for exact division. So they split the circle into 360 degrees, a multiple of 60. And once you're dividing circles into 60-based units, dividing the circle of a day, and eventually the circle of an hour, into 60-based units too, stops feeling like a leap. It feels inevitable. Centuries later, the Greek astronomer Claudius Ptolemy picked up this exact system. Working in the 2nd century, Ptolemy used Babylonian sexagesimal fractions to calculate the positions of stars and planets with far more precision than whole numbers allowed. He divided each degree into 60 smaller parts. In Latin, those became known as minutes, from pars minuta prima, meaning first small part. Divide again by 60, and you get pars minuta secunda, the second small part, the second. Pause on that for a moment. The words minute and second didn't originally describe time at all. They described fractions of a circle, 60 small slices, and then 60 smaller slices again. Time borrowed its vocabulary and its math directly from astronomers slicing up the sky. Ptolemy laid this out in his great astronomical work, the Almagest. a text so thorough it remained the standard reference for the motion of the stars for well over 1,000 years. In it, he needed a way to record star positions with enough precision that other astronomers, in other cities, decades or centuries later, could reproduce his calculations exactly. Whole numbers were too clumsy for that job. Sexagesimal fractions weren't. So the same system that once split grain sacks in ancient Sumer was now splitting the night sky into a grid, precise enough to track planets. That's the pattern worth noticing here. 60 didn't spread because someone declared it official. It spread because, again and again, whenever anyone needed serious precision, 60 was the tool already sitting on the table. For over 1,000 years after Ptolemy, this stayed mostly theoretical. Ordinary people didn't need 60-second precision. Sundials were good enough. Most days were divided roughly, by the position of the sun, by prayers, by the rhythm of work. Precision to the minute, let alone the second, simply didn't matter to daily life. Then came the mechanical clock. By the 13th and 14th centuries, European cities began building enormous public clocks. But these early machines couldn't reliably track anything smaller than an hour, sometimes not even that accurately. The real breakthrough came in 1656, when the Dutch scientist Christian Huygens built the first working pendulum clock. Suddenly, mechanical timekeeping could be accurate to within about 15 seconds a day, an almost unimaginable leap in precision. And once clocks could actually measure minutes and seconds reliably, the ancient Babylonian framework was sitting right there, ready-made, waiting to be adopted. Nobody had to invent a new system. They just had to build a machine precise enough to finally use the one that already existed. So the number 60 didn't just survive by accident. It survived because every time humanity got more precise, 60 was already the most efficient tool available for the job. Think about what that pendulum clock actually unlocked. Before Huygens, a minute was a theoretical idea astronomers used on paper. After Huygens, it was something you could hear ticking in a church tower. Precision stopped being reserved for scholars and started reaching ordinary people scheduling markets, church services, and eventually, factory shifts. Every leap in mechanical accuracy over the next 2 centuries, from pocket watches to marine chronometers used for ocean navigation, simply inherited the 60-based grid that was already waiting for it. But that raises the real twist in this story. If 60 is just an old habit, why hasn't a better, more modern system ever replaced it? Because one very nearly did. In 1793, in the chaos of the French Revolution, French reformers tried to decimalize everything: weights, measures, and yes, time. Under their new system, each day was split into 10 hours. Each hour held 100 decimal minutes. Each decimal minute held 100 decimal seconds. Clockmakers actually built and sold decimal clocks with these strange new dial faces. It failed almost immediately. Within about a year and a half, French decimal time was quietly abandoned. Why? Because by then, 60 wasn't just a number anymore. It was infrastructure. Ships navigated using minutes and seconds of latitude and longitude, borrowed directly from Ptolemy's sexagesimal circle. Astronomers, printers, and international trade networks all ran on 60-based time and 60-based angles. Switching would have meant rebuilding an entire interconnected system of science and commerce, just to make the math marginally tidier. The cost dwarfed the benefit. 60 had already won by becoming too deeply embedded to remove. Here's where the story gets even stranger. Even today, our precise 60-second minute isn't as fixed as it feels. Since 1967, the official scientific second hasn't been defined by clocks or the sky at all. It's defined by physics. 1 second is set as exactly 9,192,631,770 vibrations of a cesium-133 atom, a definition established by international standards bodies and used by every atomic clock on the planet. This definition is so precise that atomic clocks lose roughly 1 second every 100 million years. But here's the twist inside the twist. Earth itself isn't that precise. Our planet's rotation is gradually slowing down, and it wobbles slightly depending on earthquakes, ocean currents, and even melting ice. So scientists occasionally have to insert a leap second into official world time, just to keep our atomic precision clocks lined up with the actual, slightly sloppy spin of the Earth beneath our feet. Since 1972, leap seconds have been added dozens of times. The most mathematically perfect timekeeping system humans have ever built still has to bend, occasionally, to accommodate an ancient rock spinning imperfectly through space. This isn't just an academic curiosity anymore either. Modern GPS satellites, global banking networks, and internet servers all depend on atomic clock precision, measured in fractions of a second, built entirely on that same ancient 60-based scaffolding of hours, minutes, and seconds. A leap second, inserted at the wrong moment, has, in the past, caused real software glitches at major websites and stock exchanges. The stakes got serious enough that in 2022, the world's leading metrology organizations voted to phase out leap seconds entirely by the year 2035, letting atomic time and Earth's rotation quietly drift apart, instead of forcing them to match every few years. 4,000 years after Sumerian merchants first split a number into 60 pieces, engineers were still in a room, arguing about how to keep that exact same number accurate down to the atom. So here's the answer to the question we opened with. 60 seconds in a minute isn't an arbitrary accident, and it isn't some outdated relic we simply forgot to fix. It's a 4,000-year-old mathematical decision, made by Sumerian merchants dividing grain, refined by Babylonian astronomers dividing circles, formalized by a Greek astronomer dividing degrees, mechanized by a Dutch physicist building the first accurate clock, nearly overthrown by French revolutionaries, and ultimately locked in place by the sheer scale of global science, trade, and navigation that came to depend on it. Every attempt at replacing it collided with the same wall. Once a system becomes the shared language of enough people, changing it costs more than living with its quirks. Now think about your own day. Every time you glance at your phone to check the time, every meeting you schedule at 1/2 every timer you set for a minute in the microwave, you are using a counting system invented by people who never saw a clock, a phone, or a microwave. You're not just telling time. You're speaking in the mathematical dialect of an empire that vanished thousands of years before your country existed. The number 60 has outlived their cities, their language, their gods, and their entire civilization, and it's sitting quietly on your wrist right now. So the next time someone asks you why there are 60 seconds in a minute, you can tell them the real answer. It's not because 60 is simple. It's because 60 is unbreakable. Humanity tried to replace it once, with an entire revolution behind the attempt, and 60 won anyway. The question was never really why we chose 60 seconds. The real question is what it would take for anything to ever replace it. And 4,000 years later, we still don't have an answer.